And good morning to everyone. In my talk, I'd like to introduce a forthcoming multilingual research tool called AVOBMAT. It stands for Analysis and Visualization of Bibliographic Metadata and Text, and hopefully it will be soon available in the Göttingen research infrastructure. And the aim of my talk is very simple. First, I'd like to discuss the aims of this software, and then address the theoretical and methodological background behind the development of the tool. And then I'd like to illustrate the key features of AVOBMAT with two case studies, one on a long-running Hungarian literary journal, and the other is the Drakor drama collection. The first one is a proper case study. The second one is just, I'd like to illustrate the textual analytical tools. So what is the aim of this software? The idea is to provide a critical and interactive analysis of both bibliographic metadata and text at scale. That is, you can explore large collections by using data-driven and natural language processing methods. You can use transformer models as well in 24 languages on a user-friendly interface. And we have a scalable cloud-based infrastructure. As for the theoretical and methodological background, two pillars. The idea was to combine close and distant reading approaches in one single tool. And the second pillar is the integration of metadata and textual analysis. The reason for this is that I think you can ask much more sophisticated and complex research questions if you basically integrate metadata and textual analysis. This is nicely illustrated by a recent book written by Michael Gavin. This is the quotation that underlines the interplay of metadata and textual analysis. The fundamental task of quantitative literary analysis is to describe how differences in textual data correlate with differences in textual metadata. If features of a corpus cluster together in some way that persistently correspond with values in the metadata, those clusters almost certainly suggest something true about the past. Look at the last statement. I think this is a radical statement from an epistemological point of view. As for the workflow of the software, and the usual DH workflow, you start with uploading your corpus, then you have some functions to clean your corpus. You can configure the parameters for each analysis. Then you have the right or the option to test the configuration settings. It is very useful if you are working with large corpora. If you are satisfied with the configuration settings, you can go on. But if you are not, you can modify the parameters. Then you can select a sub-corpus, and then comes the analytical phase, and you can export your findings in several formats and also share your databases. It's an iterative workflow. You can go back and forth as it's an interactive tool. AVOBMAT supports a number of different formats, including TI, XML files, Zotero, RDF. Currently, we have 178 metadata fields, but we can add new fields at any time based upon your needs. And we uploaded several sample databases on GitHub. There is a metadata configuration editor in AVOBMAT for each user. You can modify, for example, the default metadata field names if you like at any time. As for the first phase of the workflow, you can upload and review your data. You will see what metadata fields were processed or has been processed. And if something is missing, you can start it again. So you can review your data and upload it again if it is needed. I mentioned earlier that you can configure each analytical tool by using different parameters. You can see two basically configurations here. For example, you can set up, you can choose either the automatic detection of languages of your corpus, or you can manually select a language out of 52 languages. On the right, you can see the configuration parameters of the topic modeling tool. There are 13 different parameters that you can set up, including lemmatization, lowercase, chunking, minimum character length. And yes, and you can again create a preview of your data set by applying these settings. And if you're not satisfied, you can go back and change the parameters. The second phase is the selection, filtering your corpus. On the left side, you can see the faceted search result. There is an advanced search function and also a command line search. And in the menu bar, you can see the different analytical tools, metadata visualization, engram, topic modeling, frequency analysis, keywording context, lexical diversity, name entity recognition, and parts of speech tagging. I can't introduce all of them for reasons of time, but we published some articles about this, and there is a website for AVOBMAT where you can check these functions. In my presentation today, I primarily focus on metadata analysis. So let's see how AVOBMAT basically enriches metadata. The first one is the language detection that I mentioned earlier. It's highly useful when you deal with, for example, library catalogs. We have seen during this workshop that metadata in catalogs are often dirty and noisy. For example, this is an example from our library catalog. And this poem is recorded as a Hungarian poem in the catalog, and our Finnish friends can immediately see that it was not written in Hungarian at all. So you can basically correct metadata with the help of textual analysis. The second enrichment type is the identification of the gender of the authors. There is a built-in dictionary of 55 countries, but you can again add your own female or male list at any time. And we also wanted to visualize data gaps and uncertainties in AVOBMAT. For example, if you think of names like G. Smith in a catalog, you can't tell whether G stands for Julia or John. And we did not leave these names out. You can see these unknown and uncertain names in green on the chart. So it's very important to visualize these uncertainties as well. The whole idea behind AVOBMAT is to foster critical analysis of your data. It always identifies and visualizes missing values for each metadata field in the faceted search and all the visualizations as well. It helps you, it helps you to highlight biases and errors in the databases related to selection, metadata, or classification biases. Again, this might be of assistance to make a more informed research decisions about decisions about your research questions. The third type of metadata is enrichment related to textual analysis is named entity recognition. AVOBMAT can identify named entities such as persons, organizations, events, and dates in 16 languages. And in 5 languages, it disambiguates these named entities and link them to Wikidata, VIAF, and ISNI. You can see as example here that this is the full text view. If you click on one entity, you will have the shortened versions of the Wikidata entry, but you can also click the BIOS as well. And we combined it with the metadata filtering. Again, this is the event facet. And if you click on, let's say, Black Death, the Wikidata entry for Black Death would come up. So we enrich this data in this way as well. All the metadata visualizations are interactive. We didn't want to have a fixed visualizations at all, because it's up to the researchers, up to your research question, what metadata fields you need. So you can select which fields you'd like to visualize and what types of visualization you'd like to use. Line, area, pie, bar, horizontal network charts are offered in AVOBMAT these days. And let's see the first case study, translations or foreign authors in the Nyugat journal. This is in English is West Hungarian journal. This was a leading literary journal in the first half of the 20th century. It's a big corpus with more than 20,000 articles. And Péter Király created the first version of the electronic version of the Nyugat, I think about 30 years ago. And this pilot study, work in progress, is part of a larger project of the Institute of Literature at the Hungarian Academy of Sciences. The title of the project was Hungarian Literature as World Literature, and I collaborated with some colleagues there. I'm not a literary scholar at all, but I helped them with the data cleaning and data enrichment and visualization. So what was the research question that we wanted to address? Basically, we wanted to identify foreign authors in Hungarian periodicals and also highlight the patterns that these translations generated. Another secondary research question was the name of the journal is West or Nyugat, and to what extent Nyugat was westward facing in terms of the actual translation published in the journal. The workflow was that we first basically decoded the pseudonyms. Then we enrich the metadata with the help of Wikidata. We use OpenRefine for this. It was highly problematic in many ways, I must admit. For example, in certain periods, in a given, the same period, the country names were different for the same or the authors of the same period. And we had to harmonize basically and refine these Wikidata entries of citizenship, and also for historical reasons. We are in the first half of the 20th century. In 1920, Hungary lost 2/3 of its territory, and 3 million Hungarian people lived outside the historic territory of Hungary. And in Wikidata, many of them were regarded, for example, as Romanian, although they wrote all their works in Hungarian. So, of course, we could not consider them as foreign authors, as they published all the articles in Hungarian, in the Nyugat and elsewhere as well. Again, as you know, the borders and names of countries changed over time. So that's why we had to oversimplify the data and harmonize it. For example, the Kingdom of France in the Wikidata entry became France. That's how we could basically disambiguate these entities. So let's see some results. You can see the country trends in Nyugat, the first top 10 countries of foreign authors. Notice the peak around 1920. I think you can't see the actual numbers. 1920, there is a maximum point of this function, and they are. This is related to basically British and American authors. You can also observe basically a peak in the second half of the 1920s. And we need to, of course, contextualize and explain these translation patterns in Nyugat. This is just an example that you can toggle on and off the different metadata fields. So, for example, I just switched off Hungary because I was only interested in the foreign authors' publications. You can see this on the second visualization, the actual authors, foreign authors in UGAT. I mentioned, for example, the peak in 1920. You can see that Edward Fitzgerald and Walt Whitman, the American author, dominated the scene in 1920, and Gorky, for example, in the second part of the 1920s. You can perform very simple network analysis with AVOBMAT. For example, here you can see the country names in green and the authors in blue and the years in red. And you can see the connections of these three entities. You can see, for example, France was very important, the French translations in the 1920s. So we won't lose a temporal aspect of our data, which is important. I think yesterday we talked about this as well when we discussed network analysis. This pie chart shows the dominant translations. Most translated works came from France, 31% of the translations, and they are related to the writings of Baudelaire, basically. Then comes the combination of metadata and full text analysis. Let's see what the full text analysis reveal. We can use, for example, the Angra viewer in AVOBMAT. I search for the same authors in the data set. You can see again Waldman or Gorky, basically, and Fitzgerald in the 1920s. The peaks are the same, and in the second half of in the 1920s, you can see you can observe the same peak, and also in the second half of the 1920s. That means that we can find several correlations between metadata analysis and full text analysis. That's what Gavin actually wrote about. Let's explain these trends, patterns of translation. The first one, the peak in 1920, might be related to the changes in the editorial board of the journal, and two new persons joined the editorial board. The French wave in the 1920s, for sure, is related to the articles by Albert Kuntz, who published several articles about French authors, and we observed several correlations between the metadata and the text analysis. For example, in case of Gorky, he was the most prominent author according to both the relative frequency of foreign authors and the distribution of their publication. This is very important finding. Of course, it's a pilot project. Much more research is needed to explain these patterns and tendencies. What were the driving forces behind these translations? We don't know who translated these works at all. So, the Dracula project, you might have heard about this major European drama project. It's open source. You can find more than 4,000 dramas on the Dracula website in 12 different languages, and CSV files are available, but we noticed that some of them are inaccurate. For example, in the TEI XML, you've got an author of a given drama, but in the CSV, the author is missing. So we try to correct these inaccuracies, and we enrich the original metadata. We added 8 new fields, such as the characters with their gender, co-authors, posthumous publications, and so forth. And basically, all the Dracula and the LTEC novel collections are available in AVOBMAT today. You can explore all of these. Let's see some examples for this interactive metadata analysis. I mentioned the co-authors. You can see in the English corpus, you can observe the rise of co-authors in the first 3 decades of the 17th century. In this network visualization, you can see the number of co-authors, 1, 2, 3, or 4, the authors themselves, and also the genre that they use. John Fletcher was one of the most active co-author, along with Thomas Middleton, for example. Okay, and now I just like to illustrate some of the textual analytical features of AVOBMAT. You can, for example, identify the significant words of a subcorpus, for example, the writings of Middleton's. You can identify the unique words characteristic of that given author according to 4 different metrics. And we have visualization as such, a word cloud with the characteristic words of these authors, but we have also the statistical data behind the visualization that you can use for further analysis. AVOBMAT supports close reading by the keyword in context analysis. So, for example, bashful was one of the unique words in Middleton's writings, and you can see the context of this word in the keyword in context function. You can also explore the context of a given keyword. You can provide the keyword itself and basically look at those words that are around this keyword. You can set up the distance between these words and the keyword itself. And as you can see, the stop words are eliminated from this visualization. At the pre-processing phase, you can perform parts of speech tags analysis as well. I was really happy when we used the transformer models, the spacey transformer models, that it could correctly identify, for example, the ancient forms of words such as die and thou as pronouns. And there is a topic modeling function. I don't have time, unfortunately, to introduce it. It has 9 parameters, and it's a long-running journal, Hungarian journal, topic modeling of a long Hungarian journal, but there are several other ways of visualizing topic modeling. So you can export the results in several ways, CSVs, PNG files, and what is important is that you can also save all your setting, all your configuration setting in JSON format. And as you can see at the bottom of the slide, there is a template window where you can actually save all your templates. You can publish them, and it helps the reproducibility and transparency of your analysis. There is a very detailed help menu with the description of the workflow, the interface overview, the configuration setting, and there is a glossary with 106 items. So you can use AVOBMAT to teach digital humanities and also data literacy. Your students can, for example, upload their own databases, but you can also use the publicly available collections such as Dracor or LTAC. To conclude, basically with these case studies, I try to demonstrate the different features of this multilingual research tool. Hopefully, I managed to highlight some overlooked patterns of translations and highlighted some signposts of new areas of research. I tried to argue in my presentation that metadata analysis is not enough. We know that metadata is biased, inaccurate, and incomplete. That's why we have seen several examples that textual analysis helps to refine and enrich metadata. This is also underlined by Gavin's argument. The central task of quantitative literary analysis is to describe variation in a corpus by finding meaningful relations between documents and their metadata. I think we have seen several examples for this in case of the NUGAT journal. So in AVOBMAT, this is the main reason why we wanted to combine metadata and textual analysis. I mean, the enriched metadata and textual analysis and the distant and close reading approaches. The AVOBMAT infrastructure is scalable, modular, and extensible. As I mentioned earlier, you can easily add new metadata. We can add other languages as well. Now it supports 16 languages, for example, NER, but in spacey, you've got 23 languages at the moment. So we can also add the missing languages. You can make your private databases public. It's very important for research projects. And As I mentioned in my introduction, hopefully it will soon available in the German Göttingen research infrastructure. Göttingen WDG is the basically technical lead of the social sciences and humanities research infrastructure in Germany. There is some data policy issue. They are updating their data policy. That's why we can't make AVOBMAT available, although according to the contract, it should have been available last year. And if you're interested, I'm more than happy to give a live demonstration in the break. You can use the LTEC or the DRACOR databases for this. And I'm more than happy to collaborate with libraries, research institutions, or individuals as well if you would like to use the software. Thank you very much for your attention.
Thank you. Questions for Robert? Jana?
Thank you for a very interesting presentation. This tool strikes me as a very simple, and it does everything that you normally do in bibliometric research. So one question, if you would use as data, let's say a scholarly journal from the 20th century, you would be able to look at the mix of authors and networks, languages, and so on. But is it possible to also look at extract citations and references and look at citation networks using this tool?
If you extracted the citations from your journals, yes. If you have your journals, for example, TEI XML, and there is you have the citation part there, you can use it for this purpose, because when you use TEI XML in AVOBMAT, you can actually choose which metadata or which elements, TEI elements, you'd like to basically pre-process and upload. But you can also use GROBID to extract, for example, citation records as well from your from the journals. Yeah, but automatically, AVOBMAT does not extract citations from the record. So yeah, this is the simple answer. But if you basically pre-process your data set accordingly, you can upload it AVOBMAT accordingly and use it for this purpose.
Thank you. A very useful tool for historical bibliometrics.
Thanks very much. How do you, when you conceptualize AVOBMAT as a tool, so what is the context or what's the competition? Is it like a Gale scholarly lab? How do you see it?
Mm-hmm.
Then the related thing is that was there like some kind of license for fee, or is it free to use, or how did it go? And then still the third or other question, just out of interest, when you did the co-author networks, or so what constitutes co-authorship there? I mean, and how you take into consideration that some co-authors.
Basically, the co-authors were recorded in the DRACOR datasets. We simply just extracted the co-authors there, which were not available in their CSV files. So the way that the directors of DRACOR defined co-authors, we accepted their basically decisions. This is a short answer. So I did not have a theoretical background of how we define a co-author in the early period. We use their data in the DRACOR project. As for the first question, the competition, the Gale Scholarly Lab, you can only analyze Gale collections. The advantage of AVOBMAT is that you can upload large corpora here, your library's data sets or databases. So it's very different. And we offer many analytical tools that are not available in, for example, the Gale system. We also use transformer models as well. I don't know what language models Gale use for this purpose. In Gale's digital Scholarly Lab, you don't have named entity linking. So there are many differences, I think, between Gale and this tool. As for the fee, it's a good question, because we rent the servers from Microsoft. We use the Azure infrastructure of Microsoft, and at some point, somebody needs to cover the server costs. We need to have a business model, definitely. now the German GWDG infrastructure covers the server cost for 6 months, and then we have to have a basic business model. All the public databases will remain public for sure, but when you, for example, pre-process a large data set, we have to somehow cover the GPU server cost. Just one example, to basically pre-process the French novels. I think you have 500 French novels in the ALTEC collection. We use the best GPUs at the Hungarian research network cloud. It basically lasted 9 hours. So that's why you need to pre-process, and we use the latest transformer models. So yeah, there must be a kind of a business model behind it. So I think did I answer all your questions? You have 3 questions. Co-editorship.
It's related. Sorry that I take it to the side, but do you make an agreement that you get to keep the data that people are? You take there's a good way of collecting all possible research data. For purposes. I don't know how trying to do how that works.
Currently, in the terms of use of AVOBMAT, which is available online, we don't collect the private data at all, so we can't see the private data. But if, for example, users agree that we can use their data for research purposes, we can basically add a new element in the terms of contract. But definitely, they should accept this as a new condition. Otherwise, this is a very important data policy, and that's what I think GWDG is working on these days. They are updating their data policy. That's why we can't make AVOBMAT available, unfortunately. So yeah, this is a data policy issue.
Yes, do we have a question?
Yeah, there's one
question.
Thank you for your presentation, a cool tool. Is it an open to use tool? And if so, how do you sign up?
If you have the website, you go for avomat.hu and you can register. So you can sign up for a newsletter, and when GWDG will basically produce this new data policy, basically all the service providers should sign this data policy. So it's not related to AVOBMAT at all. I will send a circular email to those who are interested in the use of AVOBMAT, and you can use it without charge, right? And during the 6-month pilot period, we can also upload and pre-process any databases without charge. We don't use the Göttingen infrastructure at all. We use the Hungarian research network cloud for this purpose. So this is another offer. Make use of it. Use us.
Thank you, Robert.